My name is Frank Convery. I'm the chair of the UCD Earth Institute here in UCD. And I'd like to welcome very warmly our minister, our guests, and colleagues to this session. Before I get into the kind of introductions, I would like to say thanks, first of all, to our two colleagues, Owen O'Neill and Finbar Brereton, who have been anchoring the organising of this from the School of Geography, Planning and Environmental Policy. And secondly, I would like to thank the government for supporting through PRTLI the creation and development of the UCD Earth Institute. We know that money is incredibly short. When the new government came in, we half anticipated that our project would be stopped, but it wasn't. In fact, there's a crane over there manifesting its construction at present. Hugh Brady is offering to bring guided tours for a fee of one of the few working cranes in Dublin, so it's a particular feature. But it really is important. We know from our biblical studies that only 1 out of 10 typically come back to say thanks for being cured or being financed. So we want to be the 10th who said thank you. So thank you very much indeed for that support. It's very, very critical. The flooding issue, of course, has many, many strands. It always reminds me, working as I do with various professions in UCD and otherwise, you immediately get impressed by the fact that every profession thinks it has the solution to most problems, but flooding in particular. There's a kind of professional imperative, or what the French call an idée fixe. So engineers nearly always think they can build their way out of the problem. It's a structural reflex. Planners think they can land use zone the problem out of existence. Ecologists usually say, after some thought, we shouldn't really do anything because nature has its own imperatives. Economists, of which I'm one, we think of incentives and prices as the key drivers and so on. Architects have an infinite faith in the efficacy of design. If the design is right, the outcome will be right. If you enjoyed this seminar, for example, it's not because the speakers are great, the program was great, it's because the ambience of this building was just perfect for this event, and so on. Lawyers, of course, look at liability. If only we could make local authority politicians liable for the stupidities they impose on us in terms of zoning, the problem would be solved, and so on. And the fact is, of course, that the solution is all of the above. Every piece of that jigsaw is critical. We have to design with nature, so the ecological thing is important. We have to get the incentives right. We have to get land use right. We have to get the engineering right. We have to get the legal situation right. And that really is, I suppose, what this session is an opening shot about, is trying to get those pieces of the jigsaw. The Office of Public Works is a critical engine in this whole piece of Irish policy. Richard Bruton and I, in an earlier life when we were at ESRI, we did an ex-post analysis of land drainage, which was managed then by the Office of Public Works. Interestingly, we were able to do an economic analysis because the engineers in the Office of Public Works, in the legislation that established the drainage program, they had to do essentially a benefit cost analysis. They had to look after the project. They valued the land before it was drained, they valued it afterwards. And it allowed us to look back and see many terrific projects in the more recent times then, some not so good ones. And it was, I think, one signal that that agency has that capacity to reach out beyond the, if the statute essentially requires it, they do it, and they did it extremely well. And to me, it's a kind of an exemplar of kind of broadening the tableau and the skill set and the analytical platform to essentially address this wonderfully interesting and exciting challenge. The Earth Institute that I mentioned before, which is being constructed now as we speak. The big idea we have there is to bring all the disciplines together under one roof: the engineers, the scientists, the economists, the lawyers, and so on, the planners, to address the big challenges, because we are convinced, and I think it's obvious, that we cannot progress in Ireland without doing things differently and smarter than ever before. We don't have the money, we have a lot of capacity, and the idea is that with smart science, smart technology, and smart policy, we can literally become world leaders generally. And I think this whole flooding area and the kind of interface with climate change and with other areas is, I think, a terrific example of how we can move this agenda forward. The silo mentality, which of course pervades in government, it pervades in universities, pervades everywhere. We have to find ways of breaking those down right across the board, where good ideas, good people, wherever they come from whatever perspective they have, are essentially become part of our solution. We're determined in UCD, and this Earth Institute is a partnership with Trinity and with Galway and Limerick and Queen's and so on, to do our bit to essentially bring that kind of innovation dimension to bear generally, but specifically in this area. I think probably the best job, if I were lucky enough to be an elected politician, and if I were brought in to meet the Taoiseach, if he said to me, "Frank, I'm going to make you Minister of State for Public Sector Reform and for the Office of Public Works," I would say, what a wonderful job, the best dream I could possibly imagine. We're very lucky to have the lucky person who has that combination with us to open our deliberations. Of course, he has an anchor responsibility for moving this agenda forward. So could you give a warm welcome, please, to Brian Hayes.
Good morning, ladies and gentlemen, and thank you very much. Thank you very much indeed, Frank, for that very warm and generous welcome. He says that I am a lucky politician. Every day I wake up and I say that. But Frank could also, if he given the propensity in Europe at the moment to appoint unelected technocrats to be in charge of governments, Frank could well be a nomination for that if things go really bad over the course of the next few years. It's happened in Greece, it's happened in Italy, it could happen here at some point, hopefully not. But it's a great privilege to be here, ladies and gentlemen, this morning. I want to congratulate the UCD School of Geography, Planning and Environmental Policy and the Earth Institute here in UCD. I'm glad the building is going well and that the funds are in place, as long as the Troika are here at least, to fund our way. And I want to in particular congratulate Owen and Finbar for bringing together such a range and combination of people here today. I had a chance last night to see the agenda for today, and it's really interesting because I think when we talk about flood policy and our response as government to the situation that develops, we have got to include everyone, and people's perceptions of this issue vary greatly, whether you're an economist or whether you're a scientist or an engineer in the OPW or elsewhere. Your view is coloured really as to where your perception is. So I think it's very encouraging that we bring people together during the course of today, and I want to congratulate you all for that. I'm not an engineer, unlike Tony here from the OPW and my colleagues in the OPW, but it's a great organisation, the OPW, because you bring together engineers and quantity surveyors and craftspeople and people who do a lot of things. And the great thing about engineers, they tell politicians bluntly what they think. They don't go in for spin, which is a great feature of having engineers working for you. And since I came to the Office of Public Works, one of the big areas that we have responsibility for is the coordination of national flood policy and making sure that we do what we can to radically increase the flood defences that exist in this country, but also to bring people with us across a range of organisations and a range of disciplines. And I think if we need to be reminded about the significance of this problem, it was brought home to us very starkly last October in the events that occurred on the East Coast and particularly in Dublin, and particularly the two fatalities that we had. People think of flooding as a dreadful event to one's home or one's commercial property or to lands or to beaches, whatever. But last October, if we need to be reminded, the effects of flooding in terms of people's lives were highlighted once again in terms of the two fatalities in Dublin. So this is a very important issue that we've got to get right. When I first came to the Office of Public Works, its head office is in Trim, I spoke to engineers there and they said, Minister, we have 250 hotspots. And I said, what's a hotspot? And they said to me, well, a hotspot is where we have knowledge over a period of years of a significant flooding problem that exists right the way across our country. And I think unlike many other countries, particularly in Europe, we're coming at this rather late. We have a very bad record on planning in this country, as Frank referred to. Some of the appalling decisions taken by local authorities in this country in recent years, when there was such a demand for development, do give cause for considerable worry, given the fact that the evidence-based approach upon which we now know so much more in terms of potential flood plains would have led one to the conclusion that people shouldn't have been developing there. So the state now must come in, spend money, undoing damage that needlessly was done as a result of very poor planning and development and very poor decision-making locally. So we have a huge role to play, as I said, in coordinating many different groups and organisations as part of our work within the OPW, and we take that very seriously. Now, flooding events over 50 years, I suppose, 50 years ago, flooding events were ostensibly flooding events in agricultural land. Given the urbanisation, the huge developments that have existed right the way across our cities, we now see, of course, that coming right into the heart of urban Ireland. And I don't underestimate the enormous psychological damage that flooding can bring to communities. I spend a lot of my time visiting communities up and down this country. And it's only when you actually visit a community, speak to a householder who has lost his or her possessions and their home and are out of that home for a period of time, enormous damage, psychological damage, emotional damage is done to that household, to that family. So there's a huge amount of work to do in ensuring that we put in place a flood risk management policy and the plans around that, which are evidence-based, to ensure that these events are minimised. As Minister overseeing the National Flood Protection Policy, I'm acutely aware of the need to drive forward the coordinated programmes established by the 2004 National Flood Policy Review and the transnational coordinated framework set out in the EU Flood Directives. And I think that's the important point. We now have specific EU law in this area. We have absolute responsibilities in bringing forward plans to tally with those directives, and we now intend to do that. And as you're aware, the CFRAMS process is currently underway. Now, CFRAMS, which is this big phrase that I suspect 99.9% of the Irish people have never heard about or have no interest in, but the actual words around it are the Catchment Flood Risk Assessment and Management Programme. And what that means is this: we have effectively subdivided the country into 6 river basin catchment areas for the purposes of, in the first instance, having detailed flooding maps around those catchment districts between now and the end of 2013. And then by 2015, developing significant plans around those catchment areas, how we actually address the flooding problems in each of those 6 areas. So our plan between now and 2013 is to develop these maps. We have first the preliminary maps, but they will be written off and agreed by the end of 2013. And then by 2015, we will have the whole country set out in terms of a plan for a period of decades, I presume, depending on, of course, resources where they are. Now, that's crucially important for academics and for people involved in this area, because it is evidence-based, it is an agreement, and it fits in very well with our EU directives and our EU responsibilities here. Now, that's not to say that just because we're doing all this work going around the country, setting out where the risks are in terms of a 100-year event or a 1,000-year event, that's not to say that we're not going to continue our funding between now and 2015 or 2016. That will continue, and I'll say more at the end of my remarks about that. But it means that for the first time ever, we will have a national agreement on where we see flood protection, risk assessment, the maps that are required. And that has one huge effect, and it was brought home to me recently in a visit when I launched the CFRAM pilot programme that we had in East Meath and Fingal. I said to the county manager, what is the effect of having these maps agreed? And he said, the biggest effect, Minister, is this. When local authority members propose a zoning or make comments in relation to planning, all we now have to do is transpose our flood maps, which have been agreed by your department, onto the county development plan or the local area plan, and immediately objections or proposals in terms of developments are put to one side. Now, we did not have that in the past. You could argue the mistakes that were made in the past would not have been made had we got those maps agreed at a national level. But we are going to have that in place now. And that will, I think, revolutionise the way in which we think about planning in this country and how we organise development. So the CFRAMS process currently underway is absolutely crucial in agreeing that national picture, that national framework. I should say as well, our CFRAM programme website, www.cfram.ie, is available, and the preliminary flood risk assessment maps can be found there as we go around the country. I think it's a very useful tool indeed. Can I also say, some commentators have questioned the length of time it's taking for us to develop the CFRAM study. And I think the important issue here is it takes time to get these things right. We will publish a preliminary assessment. We will then get local feedback. All of these maps won't be entirely right, but they will be controversial in the sense because they will be setting out a standard of mapping and setting out a standard that will have an impact right the way across this country for a very, very long time. So I know there's criticism of the length of time, but I would ask people to be patient with us on this because a lot of detailed work is going on and making a big difference. On the question of insurance, I, as Minister, recently met the Insurance Federation and all of the main players in insurance in this country. And I suppose their argument is that every time there's a major event, they are hit significantly in terms of the liability. It's a bit like the Economist that Frank spoke about earlier. We have, in my view, where the state invests significant capital funds in putting a flood defence in place, and clearly that flood defence has worked, as we saw in Dublin in the recent last October, the flood defence in terms of the Tolka completely held its line, held against a very significant event last October. Now, where that happens in the country, and the state puts the investment, I believe the insurance industry have a responsibility to provide insurance for people. And what we're trying to work up with the Federation and their members is at least where those funds are in place, where the capital works are in place, that at least flooding and insurance can be provided for people once those works have been completed. I want to agree with them a new protocol, as has happened in other countries, which will give that certainty to the industry and to that certainty in terms of our own organisation. We're working with them to see if we can get that right, because the exchange of information between them and us is crucial in terms of bringing some certainty to this area. On the question of expenditure, over the past 5 years, we've spent €234 million invested by the OPW on flood risk management activities. And this is made up of about 137 million spent on capital flood relief activities and about 97 million expended on maintenance of arterial drainage schemes, which we have absolute responsibility for under the existing legislation. Now, I know times are tough. The capital budgets have been reduced by about a third, given the appalling financial crisis that still inflicts the country. But we still have a capital programme. And what I was really encouraged to get the support of Minister Howlin and Minister Noonan was, through the OPW, that we have an agreed a sum of 45 million this year and every year between now and 2016 as a capital envelope for flood relief protection in this country on all capital schemes. That's a very significant decision of government. We have ring-fenced the budget for flood protection over the next 3, 4 and 5 years. And I think that allows us to, as an organisation, working with local authorities, to develop up new schemes that will make a huge difference in communities. I was in Fermoy earlier this week along the Blackwater, an area of the country that has been devastated, 7 different events over, I think, a 6-year period. Very significant flooding problem. I was able to announce a scheme there of 14.5 million. The second phase of that scheme, on the north side, the impact is in place. The south side we're now doing. So those kind of schemes will continue as long as the capital funding is there. And I think it is very significant that we have managed to ring-fence the capital budget for this year and all years between now and 2015-2016. It means this year 15 major new schemes in places like Mallow, Fermoy, Clonmel, Tipperary, Carlowtown, Waterford City, Johnstown, Mornington, Ennis, and along the River Tolka and the Dodder here in Dublin. It means that those schemes can continue. Some of them take quite some years, as you're aware, have many different phases, but it's a very important government announcement that we managed to get through. Can I also say that our department has a very successful minor works scheme, and up to €500,000 proposals can be forwarded to the Office of Public Works from all of the local authorities in the country on smaller schemes, group housing, commercial dwellings, and that kind of small relief where local authorities believe a small solution can make a big difference in terms of a group of houses there. Since 2009, the Office of Public Works has allocated 24.9, nearly 25 million in respect of 341 projects around the country. And I think the beauty of the minor works scheme for local authorities is that the applications can be given to us on a 24/7 basis. They're turned around in terms of their value. If we see a significant value as a result of doing this work, we will then give the funding to the local authority, and the local authority is the contracting agency for the funds that are to be expended there. So the major works that I referred to, this 15 schemes, and the minor works together add up to about 45 million this year, and each year between now and 2015, 2016, I think it's a significant development. Can I say this? I think it's very important that conferences like this occur around the country. The most important aspect of a public dialogue in relation to flood protection and flood warning in this country must be a dialogue with the public. It's never a problem until it arrives on your doorstep. And that's why we recently launched in the Dodder, the CFRAM's pilot programme there, involving the local authorities affected by the Dodder. And I made the point at each of those launches that public consultation is absolutely crucial. Getting people on side early on, making sure that if we have to build an embankment, if we have to build a flood wall, if we have to argue why development can't happen here as against there, that the public understand this. And I think that is absolutely the most crucial thing. Proper engagement with the public at all stages of this process, from the preliminary maps to the plans and to the delivery and execution of those plans. There is very little point in us spending a significant amount of time and resources working up a plan with the local authority, then to find that all hell breaks loose when you're trying to implement something. And I think that requires public engagement, particularly at a local authority level, when it comes to that. I want to also say as well that the major emergency management framework has been operating for some years. We play a role in that with the lead agencies, who are in most cases, well, the Department of the Environment is the lead agency, but local authorities. And I saw extraordinary coordination last October. I think we really have improved capacity here. You know, between the local authorities, the Civil Defence, the Office of Public Works, the Department of the Environment, the Gardaí, the emergency services, working together. Last October, in that dreadful event that occurred, I think we saw an example of that coordination in place. We won't get it right all of the time, and certainly we can always improve that coordination, but at the very least people worked together. And I think the next great phase of the work now is how do we develop some system, an early warning system, which can allow people to be informed of the potential event that could occur. And that's something that I know between Met Air and others we'll be working on over the course of the next few years or so. So public engagement is crucial in this, and coordination of all of the existing bodies. And it's something that's very, very important indeed. As you're aware, just before Christmas we launched the Winter Awareness Campaign, where a number of government departments came together, and that is available on a website, www.winterready.ie, which is all about informing the public of obviously the vagaries of our weather and how we respond as a public where those difficulties emerge. Given the issues of climate change, given the significant events that have occurred over the course of the last decade or so, this problem is not going away. And given also the urbanisation of our society, we have got to be prepared, but we've got to do that in a systematic, evidence-based way. And I've been hugely impressed by my colleagues in the Office of Public Works in the way in which they're involving their work, that kind of slow, dedicated work on preparing for this with a range of organisations. And we need to see that. So I'm very interested in today's conference, in your findings and any recommendations that will come from this. And I hope that we can continue to communicate with each other to ensure that government across all departments, and particularly within the OPW, is fully aware of what is taking place on the ground, and more importantly, the need for change and the need for new policy responses as they emerge. We will not get everything right here, but I think over the course of the last number of years, we're getting there in terms of that coordinated response. And as long as that can continue, allied to the funding capital commitment from government, we will get there, and we will ultimately not solve this problem, but live with this problem in a better way, and in a way that is more sustainable for our environment. Thank you very much.
Thank you very, very much indeed, Minister. I should have said, by the way, at the outset that we're very grateful to the IRCHSS, which is the research agency essentially that's funding this talk and a number of other series. The Minister, given that the geography school is central to the organisation of this, I could immediately see all the geographers clapping themselves on the back when the centrality of maps was mentioned, because it's kind of went out of fashion and suddenly maps are essentially going to define. I think there will be huge argument and debate when those maps are published, and it's absolutely critical that those of us who take a strategic view make sure that our voices are heard supporting the proposition, and obviously if they're wrong they should be corrected, but the fundamental proposition is critical. And instead of, as most of us do, sit on our hands and let the kind of major whiners take the central stage, we need to get up there and support this proposition. It's really, really important. Just a suggestion, Minister, in terms of the 45 million is a terrific achievement, by the way, given the current environment, because it's an easy investment to just say, well, we'll put it off, and we haven't put it off. We're sticking with it. When I was on the board of the NRA, I convinced the board then to put aside a little bit of money every year to fund innovation research practically applied to the challenges that the organization faced. This work was essentially driven from the inside. So the managers in the agency decided where they could see an opportunity to do something different and new, whether developing new materials, new ways of doing things, and so on. And then they went out to tender with the universities to compete. And it's still early days, but I think the payoff to that is very, very significant. So I think it would be terrific if the Office of Public Works could say, let's set aside 1 to 2% of the 45 million. 2% would be roughly $1 million a year. And have the managers in the Office of Public Works say, these are areas where we think things could be done better or newly if we took a longer view. And kind of adopt that model. It's part of, I think, the proposition that we need to embed innovation everywhere, and just ring fencing a little bit of resource and obviously you get a normal distribution of performance. 1 or 2 things will work terrifically, others won't work at all. But I think if we could do that and create this interface, because we have a lot of talent in the universities and in the third level, because it exists also in the ITs, I think it would be a great step forward. One of the kind of key agencies that is central actually to this whole area, because of course looking forward and trying to anticipate what's happening in terms of weather is a critical dimension. The Met Office in Ireland is, I think, a very, very impressive organisation. We experience it in the routine kind of predictions of the weather this afternoon, tomorrow, weekends, and so on. But there's also a strategic dimension. One of Peter Lynch has been with us as a professor from that particular organization, and the kind of interface between the practical, the kind of modeling, and the strategic is absolutely critical for this area. So we're kind of kicking off our program proper with a presentation on the climate modeling meteorology sorry, topic. So could you give a warm welcome, please, to Dr. Ray McGrath.
Met Éireann itself doesn't engage in predicting floods. We feel that our responsibility stops when the rainfall hits the ground. Now, we do obviously provide information. If we feel that there's going to be very heavy rainfall in a particular area, we will mention the likelihood of flooding. But we don't see ourselves getting engaged in hydrology and providing advice on the likelihood of flooding in particular rivers or particular catchments. So what I'm going to do is I'm going to stick to what I know best. I'm basically just going to look at the climate record of Ireland. Met Éireann monitors the climate. I'm going to focus on the precipitation and look at the statistics over the last few years. Has the rainfall patterns changed? we think they have. I'm also going to look at the difficulty that we have in forecasting extreme weather events such as flooding. And no surprise, I'm going to look at the flooding that we had a few months ago in the Dublin area. I think it's an excellent example of how difficult it is to forecast something that is very, very local. And finally, I'm going to say a few words about climate change. What do we expect in the future? What is the climate going to do? So that's basically a summary of the presentation. I'll start with a map that should be very familiar to people that are involved with flooding. It's the total annual rainfall averaged over the 30-year period. I want to show it for 2 reasons. First of all, it highlights that even when you take an annual average, the rainfall spatially is very variable across the country. Very high in the west, and it's also very high where you have mountains. So, for example, in the Wicklow Hills, you tend to get quite heavy precipitation, which has an impact on the flow of the Dodder and the flooding in the Dublin area. The other reason for showing it is that typically Met Éireann would have produced maps for the period 61 to 1990. But starting this year, the reference period for Met Éireann will be 1981 to 2010. Now, the World Meteorological Organization, they essentially advise the National Meteorological Services, and they say, look, you need to pick a 30-year period, but we'd like to have it more or less up to date. There's no point in picking a period that's quite old. The climate has changed in the meantime. So I just want to warn people that if you are getting data from Met Éireann, particularly if it's anomalies, departures from the normal, you should just check that the period corresponds to what you want. Maybe it's 61 to 90, but you should ask for that. It's interesting to compare that map with the one for 1961 to 1990. And this is a plot of the differences. It's the mean differences now. We're not looking at the extremes. I'll come to that in a moment. But you can see that over between the two 30-year periods, the mean rainfall has changed. On average, is about 5% wetter across the country. And there's a clear demarcation that in the west of the country, there has been perhaps a bit more of an increase. Perhaps not too much in the eastern side of the country, and there are in fact a few spots there. You can see a few pink colours where the rainfall has actually shown a slight decrease. So the rainfall has changed over the last 40, 50 years. If you look at the time series of the rainfall, here we're not looking at any specific station, we're looking at grid boxes averaged over the country, so the figures are perhaps a bit more robust. And you can see if you go back to the 1940s that it's highly variable. But perhaps in the last 40, 50 years, maybe a suggestion of a trend in the increase in the rainfall, which is consistent with the previous image. So on average, rainfall showing slight increases over the past few decades. If you try to break this down into seasons, it becomes much more difficult. I'm very sceptical of trend lines put into data. I often say to people, show me the plots first of all before you put in the trend line. And if it doesn't gel with the sort of visual image, I tend to be a bit sceptical that there is a trend there. So you can take these trends for what they're worth. It's suggestive that perhaps most of the change is occurring in the winter months. And perhaps in the southern months, maybe a hint of some increase, but there's a lot of noise there. If you look at the changes in intense rainfall, and I think this is probably the area that most of you would be interested in, overall, this is a plot of the increase in the number of wet days, and the threshold here is 10 millimetres per day, so quite a wet day. The change in the number of days between the two 30-year periods, 61 to 90 and 81 to 2010. Overall, there's been an increase. You can see these are just for specific stations now. The map is just to give you an indication of perhaps is there a link between the underlying topography or the data really essentially independent of that. And you can see that for colours that are blue turning to deep blue, they represent changes, increase in the frequency of days. And the lighter colours, the pinks, are for days, in fact, for situations where the stations show a decrease in the number of intense rainfall. Some stations show a decrease, but overall there is an increase. And on average, we would suggest that there's been an increase in the order of about 7%. But locally, for some of these stations, they're showing changes of the order of 20%. If you reduce the threshold and put it down to, say, 5 millimetres, then the change is about 5%. And if you go down to about 1 millimetre, which is not particularly wet, but just a wet day as opposed to a dry day, then the change is 2 to 3%. But there's no spatial trend, unlike the mean precipitation. It's quite variable across the country. So the message is that for the very heavy events, there's been perhaps a stronger increase than for the more lighter rainfall events. I'd just show a temperature graph as well. I know we're interested in the precipitation, but there is a link between rising temperatures and precipitation amounts. I'll come back to that later. This is a plot of Met Éireann's temperatures averaged over several stations, and showing it the data going back over the past century, essentially. And you've got the global average. So you've got the Irish, the green line, the running mean, and you've got the dark blue, which is the global temperatures. And you can see the trend is upwards over the past 40 years or so. Irish stations are increasing at a higher rate than the global average. Now, if you look at the trends, there's been a lot of issues about the flattening out of those curves as you come up towards recent years. But in fact, it's highly variable. Issues over, say, the occurrence or non-occurrence of El Nino will have an impact on those temperatures. We don't actually have the 2011 temperature here, but climate people tell me that it'll be up around 0.85, so the curve is heading back up. It's in positive territory. Last year it was warmer than average. It was also wetter than average last year. However, just to emphasise the variability of rainfall, it was exceptionally wet in some areas. As you might have guessed, places like Casement Aerodrome, they had the highest rainfall in any day experienced last year. That's in their records, which go back over perhaps 60 years. Whereas in another station, I think it was down in Johnstown Castle, they had the driest year on record. So, rainfall can be extremely variable across the country. If you look at the global picture, is Ireland out of step with these changes? Not really. This is the global picture, and it shows the annual rainfall going back over the past century. And you can see it's very variable, but the above normal, the green lines there are suggestive that it has been getting wetter in the last few decades. And just to show you what has happened over the last year, you can see that spatially it's quite variable. The green colours here suggest that it's got wetter, and the brown colour is drier, and the size of those circles represent the extent of the change. And you can see, as I said, it's quite variable, but in general there is a trend overall for the planet to be getting wetter. I'll now say a few words about forecasting the weather, and I'll have a look at the October 2011 flooding event. This is a snapshot of Dundrum Town Centre and the flooding that occurred there. I remember that day very well. It was actually, I'd cycled to work, and I usually tend to look at the forecast to see if it's going to be very wet and whether I should take the car or not. And I remember at around noon having a look at the forecast and thinking I should be okay getting home. In fact, the heavens opened in the afternoon, and it turned out to be extremely wet and particularly intense weather feature crossing over the country. The records indicate that around 90 to 100 millimetres is some variation in the figures, whether the rainfall measurements were official or not. But in general, you had the order of 100 millimetres falling in the space of a few hours, and not unexpectedly led to severe flooding in parts of Dublin. But it was a very local event. This is a snapshot of the forecasts that would have been available to the forecaster during the afternoon. The one on my left is the sort of main forecast, which is a grid scale of about 10 kilometres. And it suggested that there would be rainfall, maximum rainfall of about 55 millimetres, which is a substantial amount of rain. And Met Éireann and Julie put out a forecast for flooding. It didn't emphasise the severity. We're not going to say that we caught this forecast very well. I think we underestimated the extent of the flooding, that's for sure. But nevertheless, I think in general, we were in the right direction of it. The other plot on the right is a forecast from a much finer grid. It's a different model, 2.5 kilometre grid. And the forecast periods are slightly different, so you're probably thinking that those forecasts differ quite a lot, but in fact they're for slightly different periods. What I want you to do is look at the bullseyes of the maximum precipitation, those very strong red colours. And you can see that for the 2.5 kilometre grid, it was forecasting a maximum of about 90 millimetres, which is very close to what was actually observed. Unfortunately, it was too far east. It was over the Irish Sea. So if you're a forecaster and you're looking at these things, what one do you go for? That's the kind of problem that you have in trying to forecast the weather. Forecasters tend to be conservative. They're not going to shove their necks out if they feel that, particularly for something very extreme, they tend to be slightly conservative and need a bit of convincing. I might say that these kind of events, because they're so localised, that you need to have a probabilistic approach. Basically take many forecasts and see if there is a consensus as regards the rainfall amounts. This is a snapshot of a forecast that, in fact, it was 55 forecasts, and you can produced maps showing the risk of rainfall exceeding a certain threshold using these forecasts. The forecasts themselves are very similar to what Met Éireann, the same model that Met Éireann runs. And in this particular case, you just have a threshold of 4 millimetres in 3 hours. And sure enough, it indicates such as probability of, I think it's over 50% in this case. But it's slightly over the Irish Sea. So it's a heads up that something was coming. However, if I showed you the similar plots for something like, say, 10 millimetres, then the risk is dropping. It's about 25%, but it has shoved it all over the Irish Sea. So again, these probabilistic forecasts, they are the future, I think, for forecasting these very localised flooding events. But in this particular case, they did not quite deliver what they should have. You might say, well, what about the radar? The radar, well, the radar, yes, it's excellent for showing you the spatial distribution of rainfall. The reflectivity of the radar signal is very good at picking up that. However, to get quantitative amounts of precipitation, to translate the images into something that corresponds to rainfall on the ground, that is much more difficult. There are all sorts of problems. There are errors, systematic errors. You've probably seen it that we're affected by Wi-Fi signals, and you have to have filters to screen these out. You'll have ground clutter. They're probably the easiest ones to remove. They tend to be static errors that you can remove from the picture. But there are also dynamic problems, dynamic errors that occur, and it's difficult to catch these. In this particular case, the plot here shows what the radar suggested would be the total amount of rainfall. It's an observation, essentially, what the radar says, total amount of precipitation that occurred over that period. And it's underestimated. The radar itself, the estimates did not catch what was recorded in the rain gauges. So that's basically the example of how difficult it is to forecast the rainfall. A lot of work is going into improving the system. I think assimilating the radar directly into the models is the future, and there's a lot of work going on in that area. Also, the models moving down to very high resolutions. As we've seen, going to higher resolutions doesn't necessarily give you a better forecast. You introduce extra problems when you're going down to the mesoscale. You resolve these convective events, but there are problems with it. So a lot of work is going into improving the situation there. And our colleagues in ICHEC are also looking at optimizing the models. You can have very, very detailed models, but it may take several hours to run. So if you want to respond to weather events, nowcasting, introducing information, what's likely to happen over the next few hours, you need to have something that will run very quickly to give information to the forecasters. So our colleagues in ICHEC are doing some terrific work in that area there. So just to say, precipitation is stating the obvious. It's very variable. Natural variability tends to dominate. The recent records show a general increase in the averages in extreme events. The problem we have is that because the climate is changing, it's not stationary, it's not statistically stationary. So when people derive return periods, say for the occurrence of 50 millimetres or more, it's very difficult because, first of all, the climate is not stationary, and the records that you have, typically in Ireland, we do not have records extending back more than 100 years. Maybe for Valencia, you would have rainfall for 100 years or more. But in general, for a lot of the stations, the time period is much less than that. So you've got a problem that if you're doing return periods, it's quite difficult. Now, the question is climate change increasing the current risk of flooding? This is an issue before. If you went back a few years ago, we used to always say, well, we can't say. If an event occurred, is it due to climate change? We would say, well, it's more or less what the climate models are suggesting, but we can't be definitive about it. But it was an extremely interesting study done in 2011 by the UK people. And basically, they went back to their autumn 2000 flooding. And this is a map of the number of places that were actually affected by flooding during that period. Very, very widespread flooding over the UK. And basically, they ran tens of thousands of simulations of the climate with the current setup, with the current greenhouse gas concentrations in the atmosphere, and a similar setup without greenhouse gases having occurred over that period. In other words, assuming the Industrial Revolution didn't occur and that we have pre-industrial greenhouse gas concentrations. And ran sort of 1 year for that particular period, tens of thousands of these, and split the two of them in, and then looked at the differences. And sure enough, they found that just by including greenhouse gases, it did in fact increase the risk by about 20% of getting this flooding event in the year 2000. So there is some very strong evidence now that indeed global warming is increasing the risk of flooding, even though it's only just one study and for quite a large area. There is an argument that if you increase, it's what you more or less expect, that if you increase the temperature, then the atmosphere has greater capacity to absorb moisture. And there's a fundamental relationship that says that it's about 6 or 7% increase in moisture for every 1 degree rise in temperature. Now, if you look at the climate records and if you look at how the temperature has changed and the rainfall has changed, it's not 6 or 7%. The mean rainfall increases by about 3 or 4%. So there are obviously a lot more processes going on than just pumping moisture into the atmosphere and having the whole lot fall out as rain. It doesn't quite work like that. But nevertheless, when you look at extremes, there is some suggestion that perhaps the occurrence of extremes does follow this 6-7% for every 1 degree rise. And that agrees essentially with the observational record that the occurrence of extremes is increasing at a faster rate than the means. Okay, I'll move on to climate modelling then. This hasn't actually come out, there's an image there, but basically climate modelling is a two-step process. You have the global models, which tend to be very expensive to run. You have a very coarse grid, typically the order of 100 kilometres. Whereas the rainfall, you've got a lot of underlying effects that on a local scale you need to capture if you're going to look at the occurrence of flooding on very small areas such as Dublin. So you take a big model, you run it, produce projections, then you have a second model that is just running over a smaller area, say Ireland and the UK, but you can have a much higher resolution and a better representation of the surface. There are other approaches as well. I'm going to focus on this dynamical approach, whereas other people have used statistical downscaling, just taking the global data and using statistical techniques. Oh, there it is. Okay, now Met Éireann became involved in regional climate modelling, running the second model, taking the global data, running the second model. And in 2008, we produced a summary of what we felt is likely to happen. And, this is taken from the publication that was produced at that time, and it's a direct quote from it. And it suggested, yes, winter is going to get wetter in autumn and winter, and it gets some figures here, 5 to 10%. Summer is drier, but it said regional details are unreliable. And I think that is still the case. And there was a hope that we would perhaps come back and try and address this issue of the changes at a regional scale. So post C4I, we identified, first of all, that we need perhaps to get better handle on the global models. Before that, we were depending on others to produce the global simulations. But we felt that we really should have this capability in-house in Met Éireann as well. And that is something that we did. We joined up with this EC-Earth project. It's a consortium of European countries. You can see them here in the map. Met Éireann, IRCHSS and UCD, through Peter Lynch and my other colleagues, we became partners in this consortium. And in fact, we started global modelling through this initiative. This is a sort of summary how complex these models are. This is a snapshot of what goes on in the EC-Earth climate model. It's an atmosphere-ocean. It also looks at the sea ice. It's got the marine ecosystem, the land, what's happening on the land, the vegetation, the atmospheric chemistry, the aerosols. It's quite comprehensive. It's developing all the time. More and more processes are going in to make it a realistic simulation of what's going on in the atmosphere. What we've done so far is, along with our partners in UCD and IRCHSS, we provided a spin up the model, first of all. The model tends to start from something which isn't quite in balance. You have an imbalance between the atmosphere and the ocean. You let it run for about 1,000 years. In fact, it was 1,370 years. All done at IRCHSS. Very credited, I think, to that organisation. An excellent resource for kind of providing computer power. And then you run simulations for the historical period, 1850 to 2005, see how well it does it capture past climate. If it doesn't capture the past climate very well, you've no confidence in it. And then you're running into the future. Most of that work has been done. There's still 1 or 2 strands of it left, but the global data sets are out there, and they're available through Met Éireann and IRCHSS. Just to have a look at some of the results. This is the winter mean precipitation differences relative 61 to 90. You can see the grid is quite coarse. That's because it's a global model suggesting that it's getting wetter. And this RCP, it's No, I've forgotten what it is. Representative concentration pathways. This is a measure of what you expect the future will be in terms of greenhouse gas emissions. Strong signal that comes out. There's an increase in the rainfall, but a very strong signal that comes out, and perhaps people may not be terribly interested in this here. But it's drying in the summer. Very strong signal that the summer is likely to get much drier. That's perhaps maybe not a surprise, but it's something that needs to be kept in mind. That's the global model. Now, if you want to get down to finer scales, as I said, you need a second model. And this is just a snapshot of the temperature. You've got a very coarse plot there on the left, and then you use the other model, 4 kilometres, and you're picking out these details that are reflected in
3 minutes.
the other one. Okay. Extreme precipitation, the number of days. This is an example of the output that we're getting. It looks at the number of days with precipitation greater than about 70 millimetres, looking at the change 2021, 2060 and 2000 further on. And the bottom plot, says the plots, show the differences. And you can see that it's very close to what the observations are currently suggesting, that you're going to get a significant increase in the number of extreme precipitation events in the future. So what the model suggests, just a very quick summary, from the mean precipitation, wetter winters, drier summers, wetter other seasons, perhaps wetter to less extent. Changes in extreme heavy precipitation are likely to be positive across all seasons, including the summer. You may have, on average, less rainfall in the summer, but you're still going to be affected by extremes, perhaps bursts, very heavy downpours of rain during the summer. Okay, I'll just say that the data are all available, and I'll skip that. Summary. Irish precipitation climate is changing. Some of it is due to natural variability. That's often forgotten, but there is increasing evidence that global warming is making a contribution. Localised extreme events, very difficult to forecast. We're talking about operational forecasting now, but a lot of work is going into trying to improve our capability in that area. And for climate model projections indicate wetter conditions in the mean, clear signal of drier summers, increase in intense precipitation episodes overall. Current work will continue. We've got a lot of work going on with our colleagues in UCD in downscaling this information and looking specifically at extremes and how they will be changed in the future. So just to acknowledge my colleagues in Met Éireann, and I've one name I've missed in UCD, that's Conor Sweeney. I think he's in the audience. I didn't forget you, Conor. You're actually involved in this work as well. Paul Holm as well. Thank you very much.
We're looking again at the issues of perception, preparedness, and how they will inform policy and flood risk management moving forward. And if we think back to what Ray said this morning, and if we bear in mind the direction that national and European flood policy is taking us, the acceptance that we're going to have to manage risk or manage flood risk is becoming increasingly important. And the social dimension of that in the context of resilience has only gained widespread importance more recently than probabilistic and non-probabilistic uncertainties, as an example. And if I was to borrow and modify a Gordon Gekko phrase from the film Wall Street and say, fear rather than greed is good, and fear for resilience is good. So we have to qualify a statement like that, because fear promotes awareness, promotes perception, and promotes preparedness. And those pillars of resilience are very, very important in the context of a social dimension. And then we have to counter that by saying we can't have communities in vulnerable areas living in fear. So that's the complexity of the social dimension, some of which is going to be mentioned and discussed in talks in this session and talks later on this afternoon. So I want to begin. We have three very, very interesting talks in this session. And I'm delighted to welcome Dr. Ian White from the School of Environment and Development from the University of Manchester. And Ian is going to start this morning's sessions with a talk entitled Water in the City, Risk, Resilience and Planning for a Sustainable Future.
I should preface this by saying that I'm also involved in a EU project for around €5.5 million looking at flood resilience at the building scale. So essentially defences behind the defences, if you like, trying to think what if the defences fail, how can we be more precautionary. So some of the work, particularly towards the end of the session will draw upon that. I'd like to start off with this slide, partly because it just wakes people up after a coffee break, and also because on the first glance it's actually really, really terrifying. We've got the time going up here, and on the other axis we've got the number of disasters reported, or natural disasters, if you like. So, at first glance, that's quite a worrying trend. But we do need to think about the data quite differently. Since, for example, the last 20, 30 years, we've got what's called the theory of time-space compression, or in more layman's terms, the world's smaller, we get around quicker, and we know more about what's happening elsewhere. So is there more natural disasters, or is it just that we know about them more quickly? We also need to think about, well, what exactly is a natural disaster? What do you have to do to actually qualify to be on this chart? And the criteria is on the screen there, is that you need to have a certain amount of people injured and so on. And so we can start to see that how we collect data will influence how we react and how we perceive disasters to occur. And then we also have this uncertain causality. And looking at this, you might think this maps quite well onto population increases or urbanisation increases, and it does to a certain extent, but we still can't be sure that the reasons why it's happening is that simple. So why is it happening? Well, first of all, as was touched on by Ray earlier, we may be getting more extreme events which amplify the hazard, amplify the risk. The risk isn't static, it moves around. And so we're in this world where risk seems to be escalating and amplifying. And part of that is because we're getting more extreme events. More extreme events are more likely to occur. And some of the way that we manage water aren't set up for extreme events, more above average events. And that paper there is exactly the same paper that Ray referred to earlier from 2011. Then there's more social issues that perhaps, well, we play a role. It's not just weather. We're not just waiting and reacting for things to happen to us. Perhaps we're playing a role as well. Perhaps the way that we govern water makes it difficult to manage it. Perhaps the way that our institutions are set up, particularly within disciplinary silos, makes that quite difficult to talk to each other. And then perhaps more people are more exposed to risk. Not only are there more people, there's more developments, more the safer areas have gone, you've got more unsafe areas and so on. And then we've got the more people-orientated view, where perhaps certain people, or certain groups of people, certain countries, are more vulnerable to experiencing the effects. I was talking in Helsinki last year, and at the time, I think 2/3 of the country of Thailand was underwater, and yet only a certain proportion of the country was flooded, because you need to be underwater for 30 days for it to count as a flood. So those people are quite well adapted to managing water, and perhaps us in certain countries elsewhere might have some lessons, an exchange of lessons between cultures. The other thing to bear in mind is that this is essentially the transition of why it's become more the remit of planning and away from just the sole engineers, is because we're not exactly sure of the certainty of the information, and we also know that there's social aspects which we can do which really can improve the situation as well. Things we perhaps haven't had to do in the past. And this is a good example of how we actually did it in the past. This is the Isle of Tewkesbury during the 2007 floods in the UK, and this is how we defended against flooding. We built on high patches of land. They got there first in 1102, so everyone else since then has been building around them. We have urban extensions which are less safe and less at risk. So we also need to know that flooding isn't a modern phenomenon. We've always been flooded, no matter whether we were built up or not, because we've always had more extreme events. It's the way that we manage the flood risk that's become important, because if there wasn't actually that many of us around and we didn't have such a dense urban landscape, we could actually build high up. When the Dutch engineers came over and taught us how to drain land and so on, and build defences to protect against water, we started to do that. And then during the mid-20th century, that was really, until the late 20th century, that was really exposed, particularly in the UK, as not necessarily the way to go around doing things. And it also started to challenge the view of the source of flooding. And this is one of the things I want to emphasise from today's talk, is that flooding from rivers and the sea is very, very spatially convenient, particularly managerial convenient as well. We know where it is, we know where there's a line, and that's where we defend it. It's when we've got more extreme intra-urban events, surface water flooding, pluvial flooding, where essentially it's really difficult to manage because we don't know where the sources are. There's not one source of risk, there's multiple risks going around the urban area. This is the Thames in London, and it essentially exemplifies how we've managed water, an excess of water in the environment, is that we put bricks on top of other bricks, which works quite well, particularly for areas which we really want to protect, high-value areas and so on. The other point I'd like to mention is by taking this dominant approach, we've also set up institutions and professions to actually enable this to happen. So we have the Environment Agency, which is centred around flood risk rather than surface water, for example, or drainage, which is a separate institution. It's all based around probability, the actual size of the event it's meant to manage against, and so on. And so all this investment was centred around this approach. And this is something that, although works really well, as the risk shifts around flooding in the sea, it's something I think we need to temper with a slightly different approach. We also need to bear in mind that we've never known as much about water and flooding as we do now. We've never had as much money, we've never had as much probability and expertise. And if that's the case, why are we still getting flooded? So bear that in mind as we're going around this talking today, is that despite all our knowledge, we're still getting flooded. So we need to think differently about how we actually manage water and so on. So because we're still getting flooded, we saw these events, particularly in the UK, we had a huge demand for action and more ways of actually, you can always rely on the Daily Mirror to actually come up with something slightly inappropriate. But we had this huge demand to manage water differently. If we know so much about it, we're paying our taxes, we want the state to defend against it, and they weren't. So that really changed how we actually manage water. And from a UK perspective, it's this slide which really is the centre of this talk. This is where it might actually, hopefully it might surprise some of you about how knowledge, which we were very certain about in 2001, we were incredibly uncertain about 10 years later. So after the 2000 floods, which you saw on the slide before from Ray, we did an audit of, okay, how many people at risk? Because we don't know. And there was the very, very precise figure of 1,724,225, not 26, not 24, 25. We knew that for certain. And I remember when that information came out, and it's good knowledge, it's new knowledge, and we were quite certain about it. And then we had another flood event in 2002. And we actually did an audit of the amount of flood properties at risk again. And this came on the Foresight report in 2004. We've got a very similar amount of figures, but we had this new figure I'd like to draw up on, this 80,000. This was essentially the amount of people at risk from poor drainage flooding who've been registered as at risk with the drainage authorities. So we had new data that perhaps there's more than one source of flooding. It's not just the rivers and the sea, it's also the way that we manage water with regard to how we determine the pipe size, where they go, and where the houses are, and so on. And then things get really messy. And that's when everyone concerned with water just went, we might as well, let's think about things slightly differently. Because gone from 0 properties at risk from surface water and drainage flooding 10 years ago to 3,800,000 just 8 years later. And this is almost used as an example about knowledge and certainty in evidence-based planning and maps. Some of the words that we've already talked about today is that we're not actually certain how many people are at risk, and we need to bear that in mind, that when we see maps, we need to question the data, we need to question how we got it, and we need to think more precautionary despite having the maps and the evidence. So that really changed the landscape. The major source of flood risk in the UK is not from the rivers and the sea. It's from intense rainfall events in urban areas, which are so difficult to defend against, because where do you build the wall? So we also need to think carefully about using this data as well. There are definitions of risk do vary slightly between the documents. It's not an exact science. But even regarding that, it's more about certainty and knowledge than about the pure numbers. It's about how certain we are about using an evidence-based approach as the sole way to manage risk. So we've got some key issues from this small section, is that we perceive flood risk to be homogeneous. That is, it comes from one source. So we have flood risk, comes from the rivers and the sea. It's always done that for as long as we can remember. And now there's a sea change where we're starting to think, well, that's not necessarily the case. Flood risk comes from multiple sources. It comes from groundwater, it comes from poor drainage and drainage failure, and it comes from surface water flooding as well, each of which demand different managerial strategies and perhaps even governance arrangements depending on who's responsible. So perhaps we are getting better at managing floods. All that investment is working. We're just getting flooded by a different source, which is backed up by the data. We also have this reliance on engineering and engineered defences. Engineered defences have been excellent, provided really good protection to many of the cities. This talk isn't about denigrating that, it's about trying to supplement that with different approaches as well. We do need engineered defences. We also need to think about behind the defences. And then we might have what's called the principle of stationarity, whereas we saw from Ray's talk earlier, things don't stay the same, but we've assumed they do. So when we talk about a 1 in 100 year defence, it's a 1 in 100 year defence at point X, but at point Y it might be 1 in 80, as the drivers from urbanisation and the drivers from climate change the probability of that event. There's an interesting, I was in Prague, and there was a talk from the director of flooding in Prague, and they had a 1 in 1,000 year event in 1997, and then they had a 1 in 1,000 year event in 2002. And his argument was that technically it's a different millennium and that could be expected. So we need to bear in mind that there's also different ways of presenting data, and we need to be more cautious about how we use the data. And that also means broadening out our methodology for how we manage water. It's not just a case of relying on probability and quantification, because some things are really hard to quantify. Intra-urban flooding and surface water. We don't exactly know where the water is going to flow in the urban area. It could rely on the height of a curb. It could rely on poor drainage maintenance. So it's really difficult to model. And if you can't model, then you need to think more precautionary and not use the absence of data as an excuse not to act. And again, bringing that final point about how reliable that is the information we've got. It's the best we have, but we still need to treat it with caution and try and think more precautionary as well. So, in the UK, as a result of all the floods we had in the first decade of the 21st century, is that it really changed how we thought about things. We had a big event in 2007 where 2/3 of the people who got flooded weren't at risk from flooding. And that really changed the mindset of how we manage flooding. How can I be at risk from flooding if I wasn't on the flood risk maps, if I'm not at risk from flooding? It's because it came from intense rainfall events, flooding urban areas, not from the rivers and the sea. So our floodplain maps, indicative floodplain maps and so on, weren't actually this useful for this source of risk. So we have this problem that how can you defend the line if you can't actually identify where the line is? Or if there's no one line but there's multiple lines in this complex cityscape, how do you actually manage that event? And so we actually changed to a more risk management approach where we acknowledge that certain people are going to get flooded and we can't protect everyone because we don't actually know, but we can think more precautionary and we can try and protect as many people as we can, but people need to be prepared to live with water. and people need to be more resilient to these events happening. So, the final point there is that as a result of 2007, we had the PIP review in 2008, which provided recommendations that we need to manage water differently. Instead of it being the sole province of the Environment Agency and flood defence, local authorities now, from nowhere, now manage flood risk. They don't necessarily have the expertise as yet, and they're still building up the knowledge, and they're also being cut back quite harsh by the state. But that's the way the governance stands at the moment, is that the local flooding is under the province of the local authorities and not the Environment Agency, which is new. So thinking about this and what we can do about it, I'm going to talk to you a little about risk and resilience now, and try and give you some ideas about some of the research we've done at Manchester and some of the ways forward. I'm going to start off with much maligned Secretary of Defence Donald Rumsfeld with his quotation, which actually won the Poor English Award for 2002. As we know, there are known knowns. There are things we know we know. We also know there are known unknowns. That's to say there are some things we don't know, but there are also these unknown unknowns, the ones we don't know we don't know. And I think this is a case of someone being advised by some clever policy advisor or scientific advisor about the notion of risk, and it just not being translated into practice. Because what he's saying is actually right, and it encapsulates what we've talked about in the first half of the talk, is that knowledge is incomplete, and we don't know what we don't know until we have the benefit of hindsight. And so, I'm not necessarily advocating a Donald Rumsfeldian approach to flood risk management, but perhaps he was in the wrong agency. If he would have been in flooding, things might have been about. So risk and resilience. Risk, essentially based in the insurance sector, about probability, and became scientised in line with being able to work out what's the probability of an event and how can we financially recompense that. But it also created this idea that we need to measure it to act. To actually do something or make a decision, we need to know what type of risk is it? What is the probability of that event? When we think about risk, classically it's risk is hazard times vulnerability. As if you have a hazard and you have a vulnerable people, you're at risk. This has more recently been unpacked in a little bit more detail, where to have a risk you need a hazard. You need the flood event, you need the water, and then you need the exposure. You need the people spatially living in houses exposed to the risk. But you also need to be vulnerable. If you have a house on stilts or you live in flats, even though spatially you're exposed, you're not vulnerable. So thinking about it from an intervention perspective, we can address each of these elements, hazard, exposure and vulnerability, which I'm going to talk about in the next part. And this is led to this sort of new term it's come into the sort of planning lexicon, is about resilience, how we need to be more resilient. It's a very attractive term. Politicians like to be associated with it. So positive connotations like sustainability. But we need to work out what it actually means. And that's two main understandings. The first one is about this reactive engineering equilibrium approach. To sort of build resilience in a house, for example. It's quite reactive. We know it's going to flood. We're going to use different kind of air bricks to stop the water penetrating the house. We also need to adapt to our equilibrium changing, which is about different governance structures being more resilient, able to intervene in a better way. Insurance is seen as a strand of enabling people to be resilient themselves. By making insurance more available, people in turn can make themselves more resilient. So increasing the capacity to cope and respond is the second part, which also links to more the social parts of planning. So what might more sustainable, resilient cities look like? First of all, I'm going to talk about exposure, because this is one thing that we're most more comfortable with as planners, because it's what we do. It's quite spatial. Don't build on the floodplain. So we have managing the exposure to risk is something we're very comfortable with. We know that if it's in a floodplain area, we shouldn't necessarily build there. And it's the one strand of the risk triangle, the hazard, exposure and vulnerability, that we do actually do quite well, and we have done well for a while. You do need to measure it to be able to act, however. But we can actually reduce exposure quite well, given the governance mechanisms at our disposal. And then this works quite well with some of the slides that Ray had. This shape is Greater Manchester. 2.5 million people, 10 local authorities. Manchester's about the middle, Bolton, Stockport, Tameside, and so on. And then we actually did one step on from Ray's slide, is that we actually looked at the land surface area within Greater Manchester and modelled how an average type of surface, what's the runoff rate. And then because we actually tabulated the rainfall data with the land use data, we could work out how runoff might increase in an average rainfall event. And this slide has been quite good at encouraging Greater Manchester authorities to engage with green infrastructure, for example, to try and think about storing water in the urban area. So we have, on the top left, the model surface runoff, darker blue, the higher the runoff areas, and then as you get to the 2080 low and 2080s high, we're on target for the 2080s high at the moment, we should get 56% more rain, results in 82% more runoff. So we're going to get runoff behind the defences. And it also means that the other scary thing about this is that it doesn't build in any new development or land or housing over the next 70 years. So it's going to be even higher than that unless we start thinking about runoff and storing water within the urban area. And this is a similar slide. It's got the Greater Manchester authorities exploded outwards. And if you look at the arrows, that's the direction the water flows. We have the Pennine Hills around the north and the west, and the water generally runs in this direction towards Manchester and Salford. So we've modelled all where the water goes and the relative size of the event, and then we're putting the housing allocations that the government wants to build in each area. So Salford, which is already the area at most risk in Manchester, is in a little bit of trouble because no matter what they do within their administrative boundaries, and that's where their power lies, if all these new homes are built, 150,000 new homes, associated infrastructure are going to be built upstream of Salford. So they're the people who are going to manage the water and the development from Bury, Bolton and so on. So this really now indicates how we need to think about the city region and administrative boundaries being a starting point for partnerships. So we need to think about perhaps allowing Salford to develop and encouraging Bury to store water, for example, upstream, and start to think, well, why should they do that? Because they want to develop equally as much as the next area. And so you have these political discussions now about how can we adapt to a kind of environment where certain local authorities don't have the power to influence beyond the boundaries and they're at risk from the other person's policies. So it also is effective because the Conservative government, one of the first things they did when they got in power was to abolish the regional tier, which was actually quite useful for this kind of thing, to get people to think beyond their local and national boundaries. So at the moment we're in Manchester, we're working towards new partnership work. We've set up a new administrative unit called the Greater Manchester Authorities, which is all 10 authorities now working together to try and think about water across the entire city as a whole, to try and look at runoff, because Manchester is inland, and it does have some flooding from the rivers, but mainly it's interurban flooding as well. So that's the hazard. To think about the hazard's not static, it's dynamic, it's going to increase, and we need to think about tackling that as well as just where do we build. And then we also have vulnerability. which is the next part of the triangle. This it's a really illustrative picture of the police and fire station in the Carlisle 2005 floods, which was the centre of their emergency response. And so, because their fire station and police station was on the floodplain, it flooded, they couldn't respond. So thinking about vulnerability more widely is that you can be vulnerable to being able to respond by where you actually locate key agencies. I also want to stress that it's about places and people. Certain people are vulnerable and certain places are more vulnerable than others. And it's also about outcomes and context. And I'm going to touch on those 2 points in the next 2 slides. But first of all, I want to talk about this historical element that, unfortunately, we are where we are. Built form changes around 1% per annum. It really inhibits our ability to think strategically and think about the kind of city we want to live in. And this is a good example of how things don't actually change. This was the Great Fire of London in 1666. The red area is the extent of the fire. It happened on a Thursday and Friday, and it happened partly because of the materials we used. We used very wood orientated building, very close together. Fire jumped from one building to another, close together, so you couldn't get access in between to put the fire out. So the way we'd actually had the built form made us more vulnerable to experiencing a hazard. And that happened on the Thursday and Friday, and then on IRCHSS, Sir Christopher Wren on Monday, put in his new plan for rebuilding London to the King, which was based on these spacious European boulevards, where we could actually have access along lanes, to be less at risk from fire, and so on. And the reason why it didn't happen is exactly the same reason why it wouldn't happen today. It's embedded property rights. People own small parcels of land, and they just build on top and rebuild and recover and so on. So you don't actually have the power to influence spatially with some of the planning mechanisms we have. It focuses on new development, not existing. And that's a real problem for thinking about hazards like flooding. This next slide outlines what we might call outcome vulnerability, which is how you can be vulnerable due to the failure of one endpoint. This was a queue for water in a Tesco car park after the 2007 floods, where the flooding actually flooded a water and sewage station, so it couldn't provide fresh water. So we've got people now at risk from the effects of flooding who have not been flooded. So as a result, the Environment Agency decided to do a check of how many of their critical infrastructure is at risk. And it came back with some quite scary figures that saying 55% of all the water treatment works in England and Wales are at risk from flooding because they're built by the rivers on the floodplains. We have the hospitals, schools, all at risk from flooding, all are making ourselves more vulnerable to the effects of flooding. And so you can be, flooding might affect you even if you're not flooded yourself. So we have these secondary impacts as well. So that's outcome vulnerability. And now we're going to turn to what's called contextual vulnerabilities. That some people are more vulnerable than others. This is a man during the New Orleans floods, adapting quite well to his new environment. And then on the other hand, we have the east coast of England, huge amount of caravan sites all down the coast, less planning regulations on them, and certain people are more vulnerable than others, the elderly, the young, the disabled, and so on. And we have less planning regulations, for example, on caravans. They don't actually link into the emergency response systems and the warning systems, and they may not have access to escape as well as other parts of the area. So certain people are more vulnerable than others. And part of it is also due to this feeling of engagement and access to resources, is that certain parts of the population can mobilise resources and get defences built in areas and other people can't. And so perhaps as planners and people concerned with engagement and people is that we need to think about how to increase the ability to cope to people. How can we increase people so they're less vulnerable to the effects of flooding, even if they do flood it. And autonomous adaptation is essentially the Bangkok example. Is that some people do adapt without the state playing any role whatsoever. So thinking about what this might look like, trying to think about the nature of the future city, one more able to be less vulnerable and absorb more water. Now under our maps, we need to think about where the water goes, but it's where we are as well. The dots, for example, might show where our critical infrastructure is, which needs to be highly protected. Or we might have areas where we might want to restrict development due to really low sewer capacity, for example. And it's about linking the natural and the built environment. So, for example, we might have areas which are sort of green space, are more sandy, more absorbent, so more highly protected than those on clay. Clay which could actually be released for development under a different way of looking at the city rather than green belts just as a constraint for land or as a leisure purpose, more multifunctional, thinking about land having multiple purposes. But then we're thinking about resilience in practice, and particularly regarding the project we're on at the moment, is that we need to have a note of caution. Is that there's not one person who would argue against resilience on itself as its merits, and that's quite dangerous because it seems to have come through into the political landscape without the checks and balances really being applied. But when you think about what resilience might mean, there's going to be winners and losers. Resilience essentially, in a flooding world, might be applied at the building scale. And what we find out in the UK is people are now, there's a speech by a government minister last week saying exactly this, people are now expected to buy their own flood resilience measures to apply to their house. Now, this commodification of risk is going to create winners and losers. Some people can, some people can't. Richer areas might be able to move, poor areas might not. And people are now being told to be more responsible for their own flood protection. How much risk are you willing to accept? It comes up on the flood risk maps when you buy a house. If you want to live there, essentially it's going to be your issue and your problem. But what we're finding on the research is people don't necessarily buy that. They just want to be protected. You're the experts, we pay our taxes, stop it flooding. And so when we talk about resilience, we need to think about it affecting a population who might resist resilience in practice. So it's not benign, it will have effects, it will have winners and losers. That's not to say that it can't be useful, it's that it will have equity issues as well. So think about sort of key messages from this talk, is that we know flooding is dynamic. It's driven by difficult to predict and very uncertain forces. And then critically from the UK perspective, is this risk has shifted. It's shifted from rivers and the sea to intra-urban events, and that's really shook everything up. Is that we don't necessarily map these things well onto how decisions are made and how we manage water as a whole of society. So we've also had to think about our flood governance, become more precautionary, don't rely too much on quantification and evidence-based decisions. Although people in authority love evidence-based decisions because it's a way to show the paper trail for how they make those decisions. So there's more of an ownership from multiple agencies on managing flood risks together, trying to work across disciplines, which is a point Frank made right at the start about different disciplines working together, trying to complement engineering approaches with more social and planning and design features as well.
My talk follows on quite well from Ray McGrath's and more particularly Ian's presentation relating to resilience. We've done a bit of exploratory studies on Bray relating to those issues such as insurance responsibility, flood awareness, attitudes to risk. More generally, it's more an overview presentation of just some of the issues we looked at. But firstly, just going to look a little bit of context from a European perspective, Ireland, the way policy has moved over recent years, and then looking at those issues that we examined in Bray in a little bit of detail. It's more an overview though. So globally, about 3.4 billion people are exposed to one or more natural hazards and that's hazards of all sorts. So whether it's climatological, meteorological, landslides, avalanches, any of those storms, all related. Perception is that there's increasing number of events. As Ian said, these are all increasing number of events, rising costs. Are these simply explained by increased awareness? If you hooked up to Twitter last year, you could have got live feeds from the floods in Brisbane, for example. So is there just increased awareness of events because the world has got smaller, or is there actually more events? Increasing impact of climate change, as Ian referred to, and Ray also, there's 2 recent studies from Nature that have identified climate change associated with increasing episodes of flooding occurring over recent years. So 1998 to 2009 saw just over 900 major events recorded, natural hazard events. A natural hazard event being, or major event being, at least 10 fatalities, or 100 people recorded affected, or a declaration of a state of emergency. So that's what a major event is categorised as under this European database. So 2009, so 928 events, 100,000 fatalities nearly. Losses of 148 billion. Of those, only 36 billion were insured losses, and that's just Europe. Of those, 213 were flood events, so major flood events. Fatalities were 1,100, but the losses financially were a very significant proportion of those greater natural hazard events. 52 billion euro in losses, and 12 billion of that only insured losses. So looking closer to home, more recently over the last few years, we saw a number of summer floods in 2008, so localised flooding in Dublin, Wicklow, Wexford, along the east and the Midlands, major flooding in Carlow, Newcastle West and Mallow in particular towns. 2009, then we saw more regionally widespread flooding, particularly arising from the Shannon and the Lee. So just pictures here, Partine Weir in Bird Hill, Athlone, Cork city centre flooded, Ballinasloe extensively flooded, and Mallow quite extensively flooded throughout the town centre. And then we saw flooding this year again in 2000, or in just the last few months before Christmas. Rather than river flooding, a lot of that was more localised surface water issues, in addition to some episodes of river-related flooding. But the total identified cost of the 2009 floods in Ireland was 520 million, so €500 million. 276 related to the costs to the state, so damage to roads, damage to infrastructure, provision of temporary accommodation, costs incurred by the various emergency services. So that's the cost directly to the taxpayer in terms of what was financially assessed. And then 244 million consisting of damage to private infrastructure and covered by private insurance. So the estimated total cost of 520 million. But this excludes all those uninsured impacts and the costs associated, and any of the non-monetary social costs, so the psychological effects, for example, that we have a talk later on that particular related issue. So the costs can be quite extensive. There's a couple of government reports arising from the episodes of extreme events. One was flooding, the other, slightly different, was the extreme cold freeze we experienced as well. So these identified the importance of communications, preparedness and emergency planning in response to those various extreme events. I would say in general, historically, engineers have had a strong overview of flooding issues and had taken a strong lead on their research, generally being a lack of interest from social scientists until recently, now that the impacts have become more apparent, more frequent, or maybe awareness has increased. So generally there's been a lack of socioeconomic analysis of flooding in Ireland in any event, a bit more analysis of it in a European perspective. So a lack of analysis of its impact on people and on people's views of different policy responses beyond those structural solutions that we're more familiar with. So as Ray has already said, Ireland is already facing an increased likelihood of environmental hazards due to climate change. So environmental hazards may be extremes in temperature, extremes in precipitation, or extremes in winds and storms. And the risks are likely to increase over time due to climate change. So there's a number of policy responses that we can undertake to address flooding and reduce the impact. So we can introduce various forms of insurance to spread the losses. So the losses are shared by wider society through, for example, if you have a public insurance or government-led insurance scheme. Plan for the losses by raising awareness amongst people of risk, and that relief is only possible through private household level insurance. Or we can encourage people to just simply bear the losses. Individuals and companies bear the losses and cope as best as they can. So we try and mitigate those losses by trying to essentially spread them or be prepared for the loss. Or we can undertake what has been the traditional response to flooding, protection. So develop flood relief schemes to modify the risk by reducing the probability of damage through structural solutions. So at a macro level, so community level flood relief schemes, like what Finbar is going to talk about in a few minutes, that's occurring or will occur in Bray, or micro level protection at the household level, so household level resistance and or resilience measures that we also investigated in Bray. And finally, adaptation, and a lot of attention has been paid to this over the last few years in terms of climate change, so climate change adaptation. So modifying the loss potential by reducing the consequences through primarily non-structural means. So instead of trying to address the probability or reducing the probability of flooding, or intervene to introduce a threshold under which you're protected from flooding, try and introduce a mechanism to reduce the consequences through increasing flood awareness and preparedness, introducing early warning systems, emergency plans, land use planning, household level resilience measures. And I was at a talk in the UK where one of the experts in flood risk management in the London area in the Environment Agency, he was asked what was success. So we're going to develop these various mechanisms to ensure that in future developments are safe. They may still flood, but developments will be safe. And someone asked, well, what is safe? And essentially the answer was, well, there'll be no fatalities. And everyone is able to, no one gets wet feet, but really it's about minimising fatalities. People's houses may flood, people's properties may flood, but people are able to safely escape, they're warned in time and they're aware of the dangers. And at a household level, really we minimise the impact on people, focusing on people rather than property. That's one perspective, but that's the kind of agenda that has been increased over the last few years because of the costs of trying to protect properties. So the new policies are focusing on resilience, more so on resilience than on prevention, with increased attention on flood warnings, public perceptions of flood risk and flood risk awareness. To date, there's been very little research, or some research, but not extensively, on public engagement and on perceptions and attitudes to flood risk. More extensive work has been done on social vulnerability, primarily amongst sociologists, so why people locate in particular locations and what makes them vulnerable. So we did an exploratory case study in Bray, not on the structural elements, but on the non-structural socio-economic issues that we believe people would be interested in, and that people should be concerned with who live in an area that is at flood risk. So Bray, for those of you who are not familiar, located in northeast County Wicklow, 12 miles south of Dublin, population of 27,000, located on the Dargle River, and it has a coastal location, so it's exposed to some fluvial flood risks and tidal risk, and also coastal flood risk. We focus entirely on the fluvial risks. So there's been 4 major flood events in Bray during the last century: 1905, 1931, 1965, 1986, and some less significant events in 1947, 1958, and arguably in the last few months as well, there was some minor episode. So flooding in Bray occurs with an approximate average of once in every 25 to 30 years. Hurricane Charlie, which was the most recent significant event, had a return period of between approximately 50 and 100 years in the low-lying areas of Bray. So this is a map of Bray. On the left you can see just the extraction regionally. So Dublin Bay slightly to the north. The red square surrounds the physical location of Bray. And the blue line is the river running through the town, and there's some landmarks there, Super Queen People's Park, for those of you who are familiar with it, on the golf course just on the north side adjacent to the coast. So this is that area highlighted with the outline is the 1986 flood extent from Hurricane Charlie, modelled from that period of time. So in terms of a flood relief scheme that's been proposed and emerged since, the one has been designed and planned, and it was approved by Bord Pleanála in August 2008. Incidentally, an emergency flood plan was employed quite recently in September 2008, so just gives a little bit of background around recent events. So it was intended to progress this plan However, there was ongoing media speculation throughout 2011 regarding the likelihood of the scheme progressing, and this is important in the context of some of the questions we subsequently asked about, for example, people's willingness to contribute towards a future flood defence, so personally pay out of their own pocket towards one. So there was uncertainty about whether the state would definitely proceed with the scheme. So funding was reviewed in 2011, so there was some degree of uncertainty. Funding allocated in January 2012, that should be 2012, and the contracts were signed just last month, and works are now pending. So the works comprise of river works and riverside works, so degree of containment and flood walls, for example. So the survey was undertaken between August and September 2011, so just last summer, during that period where there was local media speculation as to the likelihood of the scheme definitely progressing. So we targeted the population of the flood zone and its environs. We got 305 respondents from about 1,500 properties within the 1986 floodplain and within 150 metres of the floodplain. So it's about 20%. So we gathered information on their perceptions of flooding, risk, preparedness, awareness, responsibility, who is responsible, insurance and willingness to pay. And Finbar will deal with the majority of those. I'm just going to talk about perceptions firstly. So we asked all 305 respondents to map what they perceived to be the flood zone. So thinking about the Dargle River here in Bray, this is the question we asked. Could you outline as accurately as possible on this map the likely extent of the area you believe would be affected by severe flood? For example, a flood similar in scale to that of Hurricane Charlie in 1986. And I think there was about 20% of the respondents lived through that period of time, or were resident, I should say, in Bray at that particular time. So these coloured blobs are essentially some of the responses in terms of what they perceived to be the flood zone, with 1986 being the benchmark of a major previous event. So just some of the different contributions from the various people who undertook the survey. So these are just some of the ones, and they're being overlaid on top of each other as I just move along through. Now there was 305, I'm just picking a sample of a few here. And as you can see, some from very small overlaps, some to be quite extensive, and some coincided quite exceptionally closely to what was the previous experience of flooding in Bray in 1986. This is a 2D density overlay, so it's the overlaps of all those perceptions. So the 305 perceptions all overlaid. And obviously the increase in colour, or the intensity of the colour, is indicative of the rising density. So fortunately, there's increasing density within the flood zone area. There's quite a decline towards the margins, however, but in general there is a degree of awareness about risk, a perception of the risk, and most commonly within the concentrated area around People's Park and Superquin, and it declines towards the coast and away from People's Park. And here's a 3D density overlay, just to give an overview. So this is the topographical one where we all overlaid, the overlaps overlaid on top of each other. Unfortunately, we didn't include the flood zone extent, but that's just to give an illustrative of the various observations. So there's a reasonable degree of awareness of the flood zone, and Finbar is going to talk about various issues relating to preparedness and wider awareness and responsibility. Now, I'm just going to hand you over to Finn.
Thank you, Owen. So as Owen said, I'm going to talk about some of the more headline findings that that came out of the survey. So first of all, we were interested in the number of years that the people had been at their current address. The reason we're interested in that was because the last major flooding event was in 1986. So as you can see from this graph, there's quite a sizable amount of people who didn't live through that. And I think, as John mentioned when he was opening this session, that there's a lot of people who have never experienced a major flooding event, and I think that might have influenced some of the findings that I will discuss later on. But so first of all, we were quite interested in, well, we're interested in people's attitudes to flood risk, but first of all we wanted to find out what type of people they were in terms of risk taking. So 0 over on this side is people who do not like risk, they try and avoid risk. You've got your neutrals in the middle, and then you have your bungee jumpers and other such very, very major risk takers over here. So we thought that was an interesting to get people's attitudes to risk themselves before we went on to ask them about flooding specifically. So then we asked people, in general, thinking about where you live, would you say that your home is at risk of flooding? So you can see quite a sizable, almost 50% of people do think that their homes are at risk of flooding. Then we also asked them what they believe the actual source of that flooding was. And quite a sizable majority, about 75% of people who thought they were at risk of flooding thought it was from river flooding, as opposed to coastal or runoff or any other source. Then we actually wanted to gauge who has actually been affected by flooding. So we asked people, has the house or apartment that they lived in has ever been flooded? And as you can see, it's about 28% have actually experienced a flooding event in their lifetimes. And this is mainly in the Bray area. So we asked people if it wasn't this house or apartment complex, where was it? And the majority of those were in Bray. So people in our sample have experienced flooding in Bray. And it's also quite interesting that about 80% of these people, of this 28%, of those who have experienced flooding at some stage, it was from 1986 onwards. So the 1986, I think, is quite an interesting benchmark. Then we were interested in gauging, given the previous, the amount of people that have been flooded and the amount of people that perceive themselves to be at risk, how prepared are people for flooding. And so you get the range from haven't thought about it much to I am currently fully prepared. I think it's quite striking that it's less than 20% of our sample are actually currently prepared for flooding. And again, I think that this may come back to what John was saying, that most of the people just have not experienced a flooding event, but that's speculation on our part. Then we were kind of interested in what measures they'd gone to make themselves prepared. So from check flood information brochures or websites. So this includes the OPW flooding website. I think it's flooding.ie and floodmaps.ie. All the way down to installed flood-proof household measures. So these would include floodgates, toilet valves, sink valves, etc. And again, we thought it was quite interesting that the measures that actually required investment, so that you'd have to actually invest money in, that directly protected against flooding, came very, very low down the list. So as you can see, some of the more checking your insurance cover and checking the websites, obviously it doesn't incur a financial cost. Then we thought this question was quite interesting, and I think Roisin might have some information like this as well in her presentation later. But we were interested in who people would go to or contact first in the event of an emergency, specifically in terms of flooding. So you can see quite a range of different. We had more categories than this, and people were asked, gave more categories. But this is how it panned out. So you can see the majority of people going to their local authority. Some people going to the fire service, some to the Gardaí, and then we just asked people straight out. We didn't distinguish between what we would consider as the more informal or social. So family, friends, neighbours, so not a government agency. So then people who said this, who responded in this way, we asked them again this question, specifically about the government or more formal authority that they will go to. And this is what the red figure is of these respondents. It's almost about 100 respondents, so you can see the breakdown is almost the actual responses as well. So we thought that was quite interesting. The other, in the informal category, mainly refer to people who said I wouldn't contact anyone, I'd rely on myself. And again, we thought that was quite interesting. It's about 20 or so respondents wouldn't actually contact anybody, would just rely on their own resources. So the international literature has shown a lot of different results in terms of responsibility. So if you look at the UK, it's generally people say themselves, the householder. I think at the presentation I was at in Galway last week on a similar flooding subject organised by one of our future speakers today. they show the comparison between the UK and Ireland. And Ireland, similar to the figures we found, an awful lot of people with a responsibility with the government or with the local authorities. These people who say themselves or their insurance company tend to be owner-occupiers or owning with a mortgage, as opposed to, say, local authority tenants or private tenants. We're also interested in insurance coverage. Thought it was quite interesting. We asked people, do you have household insurance at present that covers you specifically against flooding? So we asked specifically on the flooding issue. And as you can see, it's quite a substantial amount of people either don't or don't know whether they have insurance that covers themselves against flooding. We also asked their premiums in terms of the price they pay for flooding, and we found the mean to be €481 was the mean, with a standard deviation of about 173. I thought that was quite interesting, 481, because that's exactly the amount I pay myself for my own insurance. But then, for some of the people, for these people who couldn't get cover, it was only 15% of people, but we asked those whether they would be willing to invest in household flood protection measures to get cover or get a reduction in their premium. So these people were specifically asked whether they would invest in those household measures to get cover. And half of those, it's about a subsample of 50, so about 25 respondents said that they would be willing to invest to get cover. These are people who can't, who said no, that they couldn't get cover. We thought, again, that was quite an interesting finding. And it's also, I think, interesting that there's quite a low level of concern among some people. So these people were just not particularly concerned about flooding. And again, it may come back to this fear issue. The last thing that we asked people about was their willingness to pay for flood defences. And so to give you an idea, that at the time, as Owen said, of this, that this survey went ahead, there was much uncertainty about the actual about the scheme going ahead. So there was absolutely no certainty that the Bray flood relief scheme would be going ahead. And we asked people, we gave them a scenario, we gave them the likely cost, 25 million, we gave them the likely cost per Bray household, which included people in and outside the flood zone, of €3,000 per household if everybody was to pay. I think it's very, very interesting that, as you can see, almost half of the respondents in our sample were willing to pay or contribute in principle to a flood relief scheme in Bray. With the average willingness to pay of those who were willing to pay, so this is just the sample that were actually willing to pay, €231 per annum over 5 years. So it was an over a 5-year period was the scenario we gave people. So wrapping up very quickly, there's a heightened flood risk. As Owen has pointed out and other speakers, the most likely cause is climate change. In our sample, about 1/3 of respondents have experienced some level of flooding, with almost half believing that their home is at risk of flooding, and their perceptions, the people's perceptions of the flood area, tend to be very, very similar to the actual historic flood zone. It may be, it's kind of centred around the river, but what we found is relatively low levels of preparedness for a flood event, and the majority of people believing that the clean-up and cost of the flood lies beyond themselves, beyond the householder. We thought it was quite interesting again that, as you can see, 47% of people willing to pay in principle for a flood relief scheme. As Owen has said, though, that flood relief scheme is now has been confirmed and the works are pending at the moment. So thank you very much.
Again, a very interesting talk. I think it builds on some of the issues that Ian spoke about in the last presentation. And one of the things that sort of resonates with me there is that when you look at some of the numbers of the percentage of the people who actually take some sort of actions to increase their own resilience, they're incredibly low. And I think it sort of presents a question that needs to be addressed, probably from a social science perspective, in that, engaging the public and empowering them to take ownership of the flood risk is a key element to increasing resilience in the context of these flood risk management approaches that are currently being adopted.
I'm going to give you a practitioner's perspective, and in a way it's somewhat academic as well, being being a practical academic. So I'm going to take you through just a couple of points, and you might say, God, there's an awful lot of text here, and it's going to be here for hours. My aim, first and foremost, is to have you out here by 1 o'clock. That is my absolute aim. And as I said to some people earlier, if we started at 10 to 1, I'd have you out here by 1 o'clock. So I have, what, 17 minutes? So I'm going to take you through these, and you're going to see it's going to be somewhat applied, and then getting into where I'm involved in some future research that can, I hope, move on the whole area of flooding and the consequences and impacts of flooding. So we're going to look at flooding aspects, causes and influences, Ireland's route through it, vulnerability, risk assessment and managing. Just one slide on misconception, which I think could be quite important, looking at flooding in Europe and then looking at future R&D work. You'll have come across some of the terminologies I'm going to put forward here today. You'll have come across them from the previous speakers. Particularly, you'll see a lot of terminologies that Ian put up that I'm going to refer to. And like I have one very simple formula, and it's much more simple than Ian's, and it's much more from a planning point of view. But what I'm going to do here is it's going to be overlap, so hopefully you'll kind of see the joining up or the integration of them. But basically, from our point of view, flooding is to do with the chance and the consequence. So it's the chance of a flooding happened and the consequence of that occurring in your area, in your locality, in your community. And obviously we need to remove and reduce these chances and consequences. And there's various mechanisms for doing that through flood mitigation, looking at our floodplains, not developing on our floodplains, infill, emergency planning, etc. And there's then the potential for this National Flooding Agency with potential partners such as the DOE, OPW, Met Éireann, local authorities, obviously. So there's a need to kind of ramp up our approach to flooding and how we can mitigate against these chances and consequences. And as you know, when flooding starts, it's very difficult to stop it until it runs its course. But it's how we can be prepared for that, both pre and post. So we need to better prepare and better manage. And then that requires capacity building and understanding of the issue's consequences. So causes of flooding, and my pictures are not as good as Owen's previously, but we just pulled some together. And this is the flooding that's happened in Ireland over the last number of years. And if you've been affected by flooding, it's a huge impact on your life in many, many ways. And all you have to do is listen to some of the recordings on the radio from businesses that have been affected down in Cork, down in Clonmel, down in Waterford, and how 4 or 5 years after the event, they're only still getting back into their premises, starting up their business again. And these are small, really small indigenous companies that their whole livelihood has been wiped out by this event. That's totally outside their control. So it's major impacts. Like, this is phenomenal. This is like, you can see that this image here, flooding 3 or 4 foot above the actual finished floor level of the floors. And you can see, like, what I was taking by this image is that it's actually on a pretty level surface. It's not actually in a valley, or, you know, so flooding is not just applicable to low-lying areas. So again, major impacts. And typical causes of it, as you know, dams breaking, coastal rainfall, rivers, etc. So there's many consequences and causes of flooding. And then influences, like you can have storms, global warming, extreme events, vegetation, tidal, etc. So again, it's about matching and integrating these and understanding, you know, how we have to mitigate against them. So looking at our assessment of our approach to where we are in terms of flooding. So we had our major kind of coastal and river flooding in 2002, and we're all very familiar with this picture. Bertie down in Drumcondra. Don't know whether he was looking for votes or heading to Fagan's, but anyway, it still sticks in our memory, this image. We had our flooding policy then report come out in 2004. The draft guidelines 2007-2008 on risk management and flooding. Then we introduced this a system of risk management actual for local authorities and how one can start formulating plans about flooding and bringing plans and these concepts into our everyday planning policy and guidance. We had a Floods Directive that was transposed into Irish law in 2010. We obviously were very familiar with our Water Framework Directive and the various mapping and analysis of river basins that's going along with that, and how then we can start looking at a more integrated approach to critical infrastructure, residential areas, farming, playing fields, etc. I suppose one of the most important points, if we can try and get this across, is that when we had this all our Celtic Tiger, there was effectively no consideration of flooding and the impacts of flooding, which was absolutely detrimental to where we are today. However, now we need for a more evidence-led approach that we can now start looking at, areas of floodplains, dezonings, retrofitting schemes, etc. So we have time now to think and hopefully get it right and be influenced by Europe, by research such as what the research that's been done here in UCD, and by practical experiences and, I suppose, impact on people's lives. So again, Ian, as you remember, spoke about vulnerability, susceptibility, exposure. And from my point of view and the work that I'm involved, I'm just going to put forward kind of some of my simple thoughts on what these terminologies are to us as spatial planners. So to me, vulnerability is considered to be extent of harm to which it can be expected to, under certain conditions, be exposed, susceptible, or resilient. So and how do these kind of three things work together to look at this vulnerability? And like a simple formula that we use is that the more you're exposed and susceptible, the more vulnerable you're going to be. And that's kind of in any sense. Forgetting about flooding, you as a person, you as in base of employment, you as walking down the street. So the more exposed and susceptible you are, the more vulnerable you're going to be. However, if you bring in the aspect of resilience, by introducing resilience in many different forms, you can become less vulnerable. So it's that simple formula that we try to implement in our kind of spatial planning perspective. So again, it's from a flooding point of view, it's looking at exposure, it's looking at the actual impact of the disturbance, looking at the conjunction with its ability or inability to cope, recover, etc. So again, bringing these three together, you're trying to increase your resilience by reducing your exposure and susceptibility, and then give overall reduction in vulnerability, so you're less vulnerable. And you can have different elements of that, either before enduring, and during and after, and how we respond to that is absolutely critical. So trying to manage floods then, so we know I spoke about that we have flooding, which is to do with the chance of flooding and then the consequence of it. And these two coming together then is going to determine your level of impact. So again, we're looking at this exposure, so how exposed you are as a person, as a community, as an area to the flood waters, and then looking at the susceptibility of that exposure to these flood waters. So it's the exposure and susceptibility that brings together then your whole area of vulnerability. And what we're trying to get across is assessing these hazards and risks, but through preparedness, through response, and through recovery. And some of the projects I'm going to talk about now is going to hopefully enhance that approach. But just as I said about this misconception, and this is just a very simple quote that I put forward myself here. So if you experience a 1 in 10 year flood last year, it's unlikely that you experience it next year. So people think of that. You know what I mean? So, okay, we had a major flood last year. We're okay for at least another 20, 30, and hopefully 100 years, because we've been told we're in a 1 in 100 flood risk area. However, to me, that's a misconception, because 1 in 100 year is calculated to be the level of flood water expected to be equal or exceeded every 100 years on average. So it's the 100-year flood should be more accurately referred to as the 1% annual exceedance probability flood. So it's the flood that's the 1 in 100, and not the year that's the 1 in 100. So it's important to think about that. And as we all know, that level of expectancy of flooding is increasing every year because there's much more exposure, there's much more flooding occurring. So it's just to consider that misconception and how we deal with it, both in in policy and in practice. And then just very quickly looking at some of the flooding experiences throughout Europe. Like we all know, we had our the Dublin 2011 floods where 10% of our average annual rainfall fell in 6 hours. Phenomenal, absolutely phenomenal. So where's your 1 in 100 experience in that situation? We had the coastal flooding in France, worst since 1827, just along the western coast there of France. We had the floodings in Poland, Hungary and Slovakia, Italy, Venice and Rome, the United Kingdom in 2007. I always remember that image of, remember Tewkesbury? Remember the Abbey in Tewkesbury? And the Archbishop standing in the Abbey, and he had no parishioners because he was completely removed and remote from them. It was amazing, absolutely amazing. I think it was the first time in like 600 years that the parishioners couldn't actually get to the Abbey. We had Bulgaria, Germany, France, then we have the Danube and the Elbe. So you can see this is occurring on an annual event that is flooding occurring throughout Europe. And we need to be prepared for this. So this is a work that we're just going to commence. It's looking at flood-related EU research and development. It came in under Framework 7, FP7, that you may be familiar with. And we only just found out on Monday that we won it. So if we didn't win on Monday, Owen, my presentation was going to finish here. So I spoke to Owen about this, that the results may be out. So now I can talk about it, which is great. It gives me an extra few slides. Anyway, our acronym is COBACORE. And it's looking at community-based comprehensive recovery. So it's all to do with natural and man-made disasters and how we then need to respond to this, primarily from a needs assessment point of view. So the project is going to kick off in 2013, 3-year project, and our partners are TNO, major Dutch research institute, University of Ulster, the Red Cross, which is absolutely brilliant, because these are people on the ground every day working with these issues. Red Cross Netherlands and Red Cross International. We have the University of Tilburg. We have Integrate Systems, which are a Spanish high-tech software technology company. We have GeoPy, UK-based, similar type of company, but based on looking at use of GIS and spatial data management. And then we have the University of Zelina in Europe. So a very mixed bag of consortium members there. But what's great is we have these supporting partners. So we have ACAPS, which is the Assessment Capabilities Project. These are an NGO from all over Europe and the world that have come together. We have the Harvard Health Institute, we have UN Habitat, and we have ISOCRAM, which is basically an international risk management and assessment database. So pulling on their information in terms of what data they have on crisis management and how to respond to it. So so we've really good supporting partners as well as the consortium itself. And what we're looking at in this, and flooding is going to be one of our main entities, and particularly urban flooding. And there's 3 elements to it. So we need to look at how we can enhance community awareness and involvement, how we can enhance the situational awareness, and I'll talk about these, what we mean by these in a minute, and how we can improve the needs awareness and management. So it's those 3 areas, and we're looking at it both from a top down and a bottom up, and also we're looking at it from looking at needs, looking at knowledge, looking at information. They're the key things. So spatial data, spatial information is absolutely essential to the success of this project. So how we're going to deliver this then is basically like a dashboard or toolkit with 3 main models or sub-models within that dashboard and a platform of that. So we're looking at, so remember I talked about the community, the situation and the actual needs assessment. So we're looking at the communities, so we're going to develop a community model. So looking at what are the local issues about this event after happening to them. Looking at the background knowledge that they can provide of where they were before this event happened and the data sources that they can provide us with. So we have various case studies throughout Europe that we're going to use. So then we have our situation model, and this is probably one of the most important aspects of the research. So you're looking at a before and after. So again, if you think what I just said about spatial data and information, this is absolutely key. So we want to know what the place was like to the people, to the land, to the situation before the event, and how we through working with the Red Cross and the people on the ground, how we can get back to that place as quickly as possible. So obviously you can say then the information that we have prior is key to knowing where we have to go to get back to the original. You won't always get back to the original, but it's get as close as match or as an overlay as possible. So that's the situation or context model. And then we have the needs assessment model, which is basically, it's where the people, the emergency services, the people like the Red Cross, ACAPs, going onto the ground, assessing what are the needs, for not only from them of what they need, what information, what resources, what infrastructure they need to work with the community, but also what the community needs in terms of their needs, whether they're going to be displaced, how long they're going to be displaced for, when can they come back to their area, can we actually look at improving their area when they come back in. So they're the three models: community, situation and needs assessment. And it's working with these to develop this integrated enhancement mechanism. And it's basically, as I said, looking at the needs and objectives. But to deliver this then is to understand the domain of the common needs assessment, so where you're actually working in. So again, the information and data is key, because every situation will be different. Every community is different. Every community has a different set of needs and requirements. So then developing supporting environment for the common needs assessment process. So we actually need for the people to accept this. So it has to be, for them to accept it, it has to be very workable, has to be very applied, and also has to be very user-friendly. So they can, like if you can imagine, and it's only through working and discussing with the Red Cross the situations they're in, you can imagine in some situations they might actually have no access to, and this is say more third world countries, but they might have no access to internet connection or even a mobile phone. So how are they going to work? How are they going to assess the needs to get them to the people, to get the infrastructure or resources or services in? So it's supporting that environment. So it's evaluating the workplace and workspace in a realistic setting. So again, looking at the community and what the community want and what the community need, and then achieve this through the transfer of concepts and tools for stakeholder communities. So again, it's a very holistic approach, very integrated approach, and very kind of, in many ways, because we're dealing with certain areas and certain different aspects, it's a very disparate approach as well, so you have to kind of bring all of that together. So conclusions, and I've gone 10 seconds over time, so apologies for that. So there's lessons to be learned in Ireland. We have a lot of lessons to learn. We can see from the various images that have shown up there from 2002 onwards, we have lessons to learn, and hopefully through this pathwork that I've shown you of guidelines, of directives, etc., getting transposed, that we are working through this and we're learning the lessons. There's an absolute need for this National Flood Agency and some aspect of where it's going to sit, and with all integration from the various stakeholders and players, it's absolutely key. We have to be prepared. We've all spoken about this morning. Preparedness is absolutely critical, and how we ramp ourselves up for that preparedness. And you can see even some of the survey results that Finbar was talking about, and how people are being prepared. They're prepared in terms of informing themselves of knowledge of databases, but are they informing themselves of the actual, the pure infrastructure, by improving their housing, by being susceptible to flooding. So we have to be prepared in that sense. We have the capacity build, and that will help through National Flooding Agency, through guidance, through being prepared, and dissemination of project information and achievements, such as the likes of that's going on, hopefully, with the EU FP7 framework policies and projects. And we need to be proactive and not reactive. So hopefully that has given you some insights to, from a practical point of view, where we're coming from, and how even through research we're putting in our applied approach and hopefully coming out with a more evidence-led system. Thank you very much.
Thanks, William. Actually, there was a slide there that William had shown, and it was titled Misconception. And it reminded me of some work that we were doing ourselves. And as practitioners, or so-called experts in the area, we're conveying messages to the public, to stakeholders, by using terms like 1% annual exceedance probability and the 100-year flood and the 1 in 100-year event and so on. And we expect the public to actually understand what we're talking about. Sometimes we don't even know ourselves is one of the problems. And we sort of studied that actually, and a small percentage of people say they understand it. I mean, the first problem is that a small percentage of people say they understand it. So most people admit that they don't. But then actually when you test the understanding of the people who think they understand it, they don't understand it. So you're dealing with a very, very small cohort of people. And in the context of flood risk management and communications and the idea of conveying some sort of risk through probabilistic terms, the terminology that we're using is incredibly important.
Yeah.
And one of the issues, again, it might be associated with Irish people's affiliation or affinity towards horse racing or gambling, but if we express risk in terms of chance or in terms of the odds that something will happen, there's a much greater penetration of that understanding amongst the public at large. And I think that's something that the OPW are probably moving towards.